Welcome to this lesson on the properties of metals. Metals are unique materials that display three remarkable characteristics. They conduct electricity and heat efficiently, they can be hammered into thin sheets, and they can be drawn into wires. Understanding why metals have these properties requires us to explore what happens at the atomic level. Metals possess three fundamental properties that make them incredibly useful. First, they are conductive, meaning they can transfer both heat and electricity. Second, they are malleable, which means they can be hammered or pressed into sheets without breaking. Third, they are ductile, allowing them to be stretched and drawn into thin wires. All three of these properties stem from a single underlying cause, the unique way metal atoms bond together. The secret behind metal properties lies in metallic bonding. When metal atoms come together, they lose their outermost valence electrons. These electrons don't stay attached to any particular atom. Instead, they become delocalized, meaning they're free to move throughout the entire metal structure. This creates what scientists call a sea of electrons. The metal cations, which are positively charged ions, remain in fixed positions arranged in a regular lattice. These positive ions are surrounded and held together by the mobile sea of negatively charged electrons. Let's examine how metallic bonding explains electrical conductivity. The free-moving electrons in the electron sea can carry electrical charge through the metal structure. When a voltage is applied across a piece of metal, these delocalized electrons flow freely from atom to atom in response to the electrical field. This movement of electrons constitutes an electric current. Because the electrons aren't bound to specific atoms, they can move with very little resistance, making metals excellent conductors of electricity. Metallic bonding also explains why metals conduct heat so effectively. When one part of a metal is heated, the mobile electrons in that region gain kinetic energy and vibrate faster. These energetic electrons then collide with neighboring atoms and other electrons, transferring their energy throughout the metal lattice. Because electrons can move freely and rapidly through the structure, heat energy spreads quickly from the hot region to cooler regions. This is why metal objects feel cold to the touch, and why metals are used in cooking utensils and heat exchangers. Now let's understand malleability. When you hammer a piece of metal, you're applying a force that causes layers of metal atoms to slide over each other. In most materials, this would break bonds and cause fracture. However, in metals, the sea of delocalized electrons can easily adjust as atoms shift positions. The electrons continue to surround and bond the metal cations even after they've moved. This means the metallic bonds remain intact throughout the deformation process. The metal can be reshaped without breaking because the electron sea adapts to maintain bonding in the new configuration. Ductility works on the same principle as malleability, but involves stretching rather than flattening. When metal is pulled and drawn into a wire, layers of atoms slide past each other under tension. Just as with malleability, the delocalized electron sea keeps the atoms bonded together even as they reorganize into an elongated wire structure. The electrons flow and redistribute themselves to maintain the metallic bonding throughout the stretching process. This is why metals like copper and gold can be drawn into extremely thin wires without snapping. Here's the key takeaway from this lesson. All three characteristic properties of metals, conductivity, malleability, and ductility, arise from the same fundamental feature of metallic bonding. The sea of delocalized electrons surrounding positive metal ions explains why metals conduct electricity and heat, why they can be hammered into sheets, and why they can be stretched into wires. Understanding this electron sea model helps us predict and explain the behavior of metals in countless applications, from electrical wiring to construction materials to cooking equipment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.